Hi sir, in this video I'm going to show my simulation of my lab 1. So the resistor output value that at the clock with jitter value is 10 ohm, and the resistor value of R1 I changed the value is become 10 ohm, and the wavelength of the transmission line is 360. To calculate this frequency, I use the formula 1 over T, that is 1 over 0.2 nanosecond, so that the frequency is 5 gigahertz. So now with the resistor value of clock with jitter output resistor value, that at the R1 value is 20 ohm, so that is equal to 20 ohm, so that that is less than the transmission line 50 ohm. So now I start my simulation. So this is the simulation output of my the clock with jitter, and the R1 value that is 20 ohm is less than the transmission line 50 ohm. In this graph, I can say that this signal is the improperly terminated signal. So that means the signal, it has a noise and distortion in the between. So next, I had to change the value of R1 become 40 ohm, so that the R1 plus R out value is 10 ohm, is same with the transmission line 50 ohm. So now I start my simulation. So this is the simulation output graph that I get. So in this graph, I can say that the signal has no reflection at the transmission line. So next is I had to change the value of R1 become 110 ohm. R out value of the at the clock with jitter plus R1 value of the resistor is total is 120 ohm. That is more than the transmission line 50 ohm. So now I start my simulation. So this is the graph that I get. So in this graph, I can say that this is a matched digital signal is due to the R out value at the clock register plus R1 value is more than the transmission line of the transmission line 50 ohm. That's all for my video. Thank you, sir.